Hey guys, today we're going to be taking a look at what are homogeneous functions, and first let's start off with a definition. So the definition of a homogeneous function is a function is called homogeneous of degree n if f of lambda x comma lambda y is equal to lambda n f of x comma y. Now this might not make sense at first, but I promise you it will start to make sense as soon as we're done with this example. So I'm going to rewrite this function as the left-hand side. So I'm going to add those lambdas. And lambda in this case is just a constant. So I'm going to have f of lambda x comma lambda y. Every single time I see an x, I'm going to replace that with lambda x because that's what we have over here. And every time I see a y, I'm going to replace it with lambda y over here because lambda y is over there. So I'm going to have lambda x squared minus lambda y squared plus 3 lambda x and lambda y. And then from here, I'm going to simplify. So lambda squared x squared minus lambda squared y squared plus 3 lambda squared xy. And a common factor I see here is definitely the lambda squared. So I'm going to take that out. And what do you know? This exact thing is exactly what we had in the question. And what we had in the question is f of x comma y. So I'm going to replace the thing in parentheses with f of x comma y. And just like that, this is definitely in the form of this, so we can say that this is a homogeneous function. But we don't stop right there. We need to know what degree this homogeneous function is in. So the degree this homogeneous function is in is going to be of degree n, so degree of n right over here. So this is going to be a homogeneous function, homogeneous of degree of, and n in this case is 2 because that's the power of lambda. So homogeneous of degree 2. And that is pretty much an overview of how you find homogeneous functions as well as an example.